Can see the sharing screen. Okay,
Okay,
good.
good.
So yeah, sorry about that. I got
Okay.
a little busy recently, so I'll have another talk today. So it's a little bit or like a suit up today. 我下午要去演讲，所以今天穿的早上我刚刚才从南科赶回来，哇，这下雨天从南科回来真的是一场噩梦，非常的可怕。那个我平常开这段路只要25分钟，我今天开了将近75分钟，那这个 I don't know why, but the traffic disaster, yeah，就是好像下雨天大家都那开车之外，大家技术也不会变更好，所以很可怕。我光一路上发生3个车祸，那沿路从南科回来的3个车祸就是yeah, it's a totally disaster, yeah. So yeah, sorry about that. And today we're going to talk about machine learning and deep learning. So this is going to be a book. So I'm still working on it. So as you can see that just if you read it, anything is maybe you feel like it could be better, let me know how to revise it and let me know your suggestion and comments. Okay, so today we're going to talk about the fundamental of machine learning and deep learning. It's going to be a quick review and quick briefing for all this stuff. So I think I assume all of you have finished the Python language programming lectures online and also finished the test, right? So the quiz that yes, I think last week, it's just really, I think it's promising learning result from all of you. So we can start working on it. Then, because it's kind of involving with Python programming, so I need to make sure that all of you get the fundamental ability for that. Okay. And Shamal, please, you should mute yourself. Yeah, okay, good. Good. So, in today's lecture, we're not gonna go through everything because you see that this is 73 pages for today. It's gonna be a very long textbook. So the textbook is for you to read. I'm just gonna show some very important or summarize some of them for you. Okay. So today we're going to talk about machine learning. So this is gonna be something like this. It's what's gonna happen for today. We're going to talk about machine learning. But before that, we'll talk about some background of AI and what is the difference from AI to machine learning. And then this is like a subfield. So if you take a look like this, some of you may have seen this. This is if this is domain of AI. This is the domain of AI. We call it artificial intelligence. Then there's gonna be a subfield. We call it subfield. Subfield like this. This field belongs to machine learning. Sorry. This field belongs to machine learning. So, and also we'll some administrative processing to say that we'll have a midterm. So the midterm gonna be. I think where's the midterm? The day of midterm? 新会，我们期中考的日期是什么时候？4月22号。Okay, so it's gonna be April 22nd. April APR 22nd. Okay, so the midterm. So the midterm gonna be something like this. Like your quiz, they're gonna be programming and some handwriting. We will have some handwriting, like the relatives and short answer, like a short quiz. And also we're gonna involve lots of programming. Okay, for that. And so we'll announce maybe a mock exam. before the meeting, before the midterm exam. So don't worry about that. And it's also open book, and so you can bring everything you need. Don't have to worry about the syntax, the details, everything. The things you need to do is to understand how to use this kind of syntax and how to solving problems with the technique we've been mentioned in this lecture. Okay, so this is subfield of machine learning. So what's the difference between AI and machine learning is what we're gonna show you today. And also there will be a very specific domain we're gonna cover most of the time during this semester is this. This we call deep learning. Oh, sorry. So what is the difference from machine learning to deep learning? Is a major, I think it's a major thinking problem that you need to think about. So one of my students graduated 2 years ago. He's now in 他叫伟创嘛，他现在在伟创工作做 IT 的。So the student who actually got an interview with TSMC IT department， 他本来在我的团队里面的时候，他其实我帮他介绍到 IT 团队去在 TSMC。那 so the supervisor, he's my friend, so he called my and asked about the question. So the first question is, what is the difference between machine learning and deep learning? And my student got stunned. He said, I don't know. Yeah. So he lost the chance. But yeah, so this is a fundamental question. If you'd like to apply a job in industry or the IT industry, especially for IT industry, like to be an AI engineer, then you should better understand what's the difference between machine learning and deep learning. Okay, so it's part of a machine learning, but it's quite different from machine learning. So that's why you have all the applications today. You can see the ChatGPT, see the Midjourney, everything that recently you can find. So today we're going to talk about that. What is artificial intelligence? The first thing is, what is AI? The AI is the program that we like to make computer to do things that is automatically or without explicitly programmed. So you like to make the computer. You like to make the computer smarter without explicitly programmed. So this is the major, the core idea. I think the essential idea is what is artificial intelligence? It's called intelligence, which means they can get some ability to make it smarter. Okay, so without explicitly programmed, which means it's not specifically ruled, which means not specifically ruled. Sorry. Specifically ruled. So let me show you something. If there's a rule, there's a certain rules that you can follow, like F equals to ma. This is what we call Newton's second law of motion, right? If you do have some rules that you can follow, then you can just program it, right? You can just program it using a function. Then you can always have your accelerations, and with mass, then you can calculate the force being applied to this object. So it's really easy. You don't have to use machine learning to do so. Like a gravity, like a universal law of gravity, you can just use the equation to do so. And there's a specific rule for that. Then you don't have to use machine learning or AI to do so because they already have the rule. But sometimes you don't know what the exactly rule is. So that's the reason you need it. That's the reason you need AI to do so. Okay. And then the other thing is, what is machine learning? What is machine learning? Machine learning, different. So if the computer program have the ability to do it without the explicit program, that you can call it artificial intelligence. It involves several different kinds of technologies they can do, like genetic algorithm. So genetic algorithm, you don't have to explicit program, but they can find out some certain special case for the optimization process that we call it genetic algorithm. For instance, we call it GA. But in machine learning, there are some specific important things that you need to follow, which involves data. Now you see that from artificial intelligence, just the idea of philosophical result that from the programming that you don't have to do it explicitly. So no matter what kind of program they can do it involving by themselves for any kind of purpose, then you can say that it's one of the artificial intelligence. But instead of we talking about learning, the thing that's important is you involve some data. The data should be the key or essential part or the core of the machine learning. So learning from what? Learning from data, then that's machine learning. Then that's all you need to understand. Okay, so if someone just ask you, what is the difference from artificial intelligence, major difference from artificial intelligence to machine learning, then the source is data. Okay, so artificial intelligence don't have to, it's not necessary to involve data, like genetic algorithm, like what I say, you don't have to use data. Okay, but in machine learning, you always need data. So that's why we are always in like 2010, people are talking about big data, always use big data, talk about big data, mega data, because machine learning is just showing up the potential applications that back then. Okay, so it's about data. So the major difference from that. Okay, so what we do before without data, the things we do is we have some input. We have some inputs. Then we put them back, put them into a machine, a program. That program we got it. We call it a code or program. Okay. We have a program. So you use this program, then they can give you some. Yes, your output. Okay. This is, oh, sorry. It's tedious, ugly. Let me reframe it. Sorry about that. Okay. So let's do it again. Okay. Oh, sorry. Eh, sorry. What happened? Oh, good. Now it's better. We've got, oh, sorry.
这个会自
我
动变化。
知道了，哎，谢谢。Input yeah, good. We can have. Oh, sorry. Yeah, good. Output. Okay. Oh, sorry. 哎，慧姐，它怎么变这样？这个啊。So here, usually this is the basic way that we do programming. Like this is the ordinary programming. Ordinary programming that we do here is like this. So
Here is the program, so the specific thing that you want the program to do, so you need to rules, right? You need to impose some rules here. Okay, now in machine learning, now with machine learning, what we have here is we got output. Oh, sorry. We got output and input. Sorry. Now it's another program. We call it model. We call it model. Then they will show you
Okay. So in machine learning respect, that we have some inputs and outputs. We put them into the model together. So you already collect the input and output, but we like to understand what the correlation between input and output. What's the relationship between input and outputs? So we put them into a model, and this process we call it learning. So this is the learning process. We put them into a model, and after training, you got the results back. So they give you some certain rules. And please be cautious. This kind of rules may not be universal. It may be universal. It may not be universal. It sometimes correlate to some false rules. I will show you. Some examples later. Okay. So now I hope you understand the several key terminologies we need to understand. Okay. So the first thing is we call it data. The data should include several different key aspects. One is for data, the first is features. What is the features of this data? Features 在中文叫特征嘛，就是中文的，就是它到底有哪些特征？ Let me show you some example for students. For a single student, they may have some student ID as a feature, some gender. Now in United States, you only have 2 genders, but yeah, let's not talk about that. But yes, so gender is a feature, and also your height, your weight, your birthday is kind of features, right? So there are several features representing what is the piece of data. So in data, it's uncountable. Okay, so I really can stand the people talk about. I show you some data. No, there's no data. Data is uncountable. Data 是不可数的。那要数 data 怎么办呢？它叫一片一片的哦。A piece of data or several pieces of data or large amount of data. It's not data. Okay, so when we talk about data, the features is important. So how to find out the most important features is one key like engineering aspect for machine learning. So before we I think in like a 2000 to 2000 1990s to 2000 during this decade, people are working devote several effort into this we call feature engineering to find out what is the most important feature in machine learning in data. Okay, so in features, the feature is used to represent. To represent data, and we need output. But in here, we're not talking about
we are not talking about outputs. We use another thing. We call it label. Okay, we call it some labels. Labels, they got two things. There may be more than two types, but we can show you only. For now, we'll show you two types. One is the label can be continuously or discrete. Discrete. Okay. So in Chinese, in Mandarin, in Chinese, it's called 连续或者是离散。OK， 你们在修computer science 的课的时候，其实很重要的就是离散数学哦，这就是 discrete。OK， so the label could be continuously or discrete. So what is we call continuous label? We like to the label could be a number. This number may be the price of stock, price of a certain stock, or your blood pressure, something like this. 就是它可能是一个连续的数值，可能是股价啦，可能是房价啦，可能是你的血压啦，可能是任何事情，just a number. This number could be a continuous number, right? So there is there's just continuous distribution for, and some discrete label. Maybe good or bad, yes or no. Okay, you have something good, something bad, something you call it it's qualified or unqualified. 就是你可以把它分类成好的或不好的，或者是合格或不合格的啊，这样当然也可以做更多的分。You can use it with more discretized labels. Maybe for the handwriting digit, we'll show you later. The handwriting digits from 0 to 9, they have like 10 labels, right? So it could be discretized or could be continuously. So there will be two different types of model that we will have to use. One is for this one, we call the regression problem. This is regression. And for this one, we call it classification. Okay, is it good? So there will be several different kind of model that you can use to understand what is regression, what is classifications. They can perform different tasks for regression and classification. But if someone asks you, what is the major difference, the main difference from regression problem to the classification problem is the label, the different labels. One is a continuous label that you can use that belongs to regression problem. If this is a discretized label, then this belongs to classification problem. Okay. So, but some problem could be a certain problem could be either regression or classification problem. Let me show you. So if you like to predict, let me show you some example. If you like to predict, if we like to predict a stock market, okay, so there are several indexes for the stock market, right? For like what I understand for maybe for TSMC or maybe for this certain, like we call it 0500 ，OK， 就叫台湾500啊。如果有在投资的同学都知道这一支哈，这支就是一个你觉得放定存划不来的人就会丢这一支啊，就是它就是很稳定啊，获利率就大概4到5%，也不会太差啊。那就只要台股好的时候它就好，台股不好的时候它就不好，就是这样。它是台湾500啊，0500就元大发行的。So for this one, okay, so there could be. If you like to predict the price, it could be either regression problem or either classification problem. For regression problem, we like to predict the exact price. We like to predict the price, the exact price. Then it belongs to regression, right? It's a regression problem. It's a regression. But if we like to predict, is it gonna goes up or goes down? Is it gonna go up and go down? Then it's be the two labels, right? It's up or down, right? And maybe three is remain the same, go up or go down. So it's a classification problem. So if we like to understand the trend, maybe goes up, goes down, oh, nothing changed. So it's become classification. So it depends on the target you like to predict. It depends on what you like to understand. It depends on how you want your model to do, and it also depends on the data. How many data you can, how much, and what is the amount of data you can obtain, and you can process. How many value you can extract from the data, and it belongs to this kind of different kind of categories of the problem. So one is the price, one is the trend, and you can distinguish them from each other. Okay, so this is a major difference from that is because of the label. OK， 所以同样的问题有可能是回归的，有可能是 regression， 也有可能是 classification， 这个就看各位你们想用怎么 model 去预测什么样的事情啊 ，it depends on that. OK, so any questions? OK, so this is the overview of machine learning and data and like what is the difference for machine learning and artificial? I will show those. Let's go back to the lecture. I will upload this annotated version to maybe to the Moodle. I think 上次还没上课，这是那个 machine learning IL 的有上传的吗 ？Okay, so we'll also upload it this to the coursework side, to the Moodle. Okay, so for this we call you machine learning. Okay, so the machine learning you can read it if you have time, but we call it rule-based system before, or symbolic AI. And it's not very ancient time. I don't know if you know, 有一个很有名的人叫李开复啊。李开复是当时在 Apple 做最早期的 Siri 啊，最早期的语音辨识学家哈。那个时候其实他们很大部分的就是we call it personal digital assistants is based on rule base， 就是它后面就是一堆 if else 啊 ，is a lot of if else。A lot of rules, following by first layer of rules and second order of rule, and then there are several different orders of the rules they should follow, and then you can perform some very complex tasks. Okay, and to the modern era of deep learning, we'll talk about modern deep learning and the large scale data analytics today. Okay, so. I'd like to mention that today machine learning is not only a core component of scientific inquiries, but also a critical envelope for solving complex problems in several different cases, like healthcare, finance, transportation, and beyond. Lots of the different industries, they all have to use AI. Okay. So the historical progression, I think, in machine learning, that I will leave this paragraph to you. Okay. So in recent years of the development of deep learning, it's very important to understand what's the deep learning. So we'll show you deep learning, but the deep learning is based on the capability of GPUs and TPUs. It's called tensor process unit here. TPU is tensor process. And reinforcement learning for decision-making task. So we'll have we gave another lectures. We have another lectures on reinforcement learning to talk about all the algorithms, the details, and optimizations in separate lectures. Okay. Good. And then we'll have it. So let me show you some examples. Especially for the computer vision. So the progress of AI, progress of machine learning, or progress of deep learning, been the first showcasing is computer vision. So we usually like to use computer to identify objects in the photo, in the video, in everything. So people are working on that. They can use like a computer visions, computer tasks to categorize, to automatically identify for humans. Like what you can so recently, if you drive into like a careful, 你如果开车进家乐福的话哦， they can have automatically like a plate license identifications for you. The system can automatically just classify what is your plate number, plate license number. 然后，所以其实像这样的系统，其实在早期是不可能的。And usually, what is the parking system? 各位有没有去过远东百货？就是在站前那间 ，We got a Fast the department store. So if you go downstairs for the the parking garage, you have to take a token, right? You have to take a code. 他那是给你一个代币，你就拿一个 token. So usually we do it or a license like a card that you can just record the time you entering the parking garage. But now it's automatically been recorded and identified by the AI. So the computer vision is the first thing that's stunning people. So in 2014, so this is in 2014. In 2014, we got a competition for the computer vision. The winner is from CMU. Anyone knows CMU, the Carnegie Mellon University, and in CMU 就是卡内基美农啊，它是一个非常有名的一间。如果你立志要学 computer science， 那你想去 Google， 想去 Amazon， 想去 Facebook， 现在叫 Meta， 这几间大公司，或者是去像 Lyft 这种。在美国的叫做科技新秀公司的 New Tech companies, then your bad choice is go to CMU or the UC Berkeley. 这几间大学就是你其实要进到这几间有名的这种我们讲说叫做新的科技公司的话，其实他们最容易进去的几间学校，其中第一个就是 CMU. So in CMU, 他有一个教授非常的有名 ，There's a professor called Hinton, Gregory Hinton. 那你一定要认识他，为什么？他今年拿了诺贝尔奖，他拿的是诺贝尔物理奖 ，right？ 他拿的是 Nobel Prize in Physics. Hinton. They use deep learning model to excel in this competition. 他们用了一个深度学习的网络 because they have proposed a very important technologies in the algorithm. We call it backpropagation. We'll show you the detail in next lecture. Okay. So in 2014, and also there will be there's another one there for that. Another one for that is another company called NVIDIA. In 2008, NVIDIA proposed a new computational framework called CUDA. Anyone knows what is CUDA? 有没有人听过 CUDA 的? Raise your hand if you ever heard about it before. No one? Okay, so you should better get familiar with CUDA because you're going to use it for a very long time if you're using GPU, machine learning, or AI, or deep learning. Now, I'm sure all of you need it to understand what is CUDA. I used CUDA in 2010。在我念博士班的时候，其实我用了 CUDA 用了一阵子啊。那个时候我们用来解 PDE 啊，就是用来解一些偏微分方程式是非常艰难的一个任务哈。那个时候 CUDA 最大的问题就是它记忆体很小，那时候记忆体小到一个程度，是你基本上得一直搬你的储存的东西搬来搬去。So CUDA。And they use NVIDIA's GPU with CUDA to train the neural network and get a huge successful in this domain. So that's why people are using GPUs recently. You heard about that? The people are talking about GPU everywhere. Right? You can hear it's like an internet hype. Everybody now understand what is GPU, what is AI, what is the GPU computing now. OK, CUDA. 所以在这个时代，其实我们现在为什么会有这样子的辉煌的年代，其实跟 CUDA 有很大的关系。OK, so then we have moved to a new different area. So this is what we call deep learning. So what is deep learning? What is the difference from machine learning? So let me show you some cases in deep learning and machine learning that will have a totally different. So for computer vision, usually people use machine learning to do so, but they require a lot of the feature expressions to do so. So if you like to do machine learning for the computer vision, like identify numbers, then you need to first extract the features from photos. 比如说这里有一张照片，写了一个数字9，你必须要人工把它的 feature 挑出来。好，就你必须要找到它的 feature。那这一点是非常艰难的，在当年，所以当时其实很多的工程师设计了一些叫做 filter。We apply lots of filters to do data processing, signal processing before put them into the machine learning model. But in deep learning, the good thing is we can do end-to-end. Then we input a data is an image to this model that give you results. It's a 9. Okay, how can this be? And how could this be? We got the photos directly. So this is raw data. Raw data to a certain deep learning model, especially for the deep learning model, they just give you a result. Okay, before the machine learnings, before the deep learnings, you need to extract features from the photo. So you need to understand how to get these features out. So you apply lots of filters to do signal processing, lots of different kind of applications to find out, okay, so this is the feature we can reconstruct the photo or represent this photo or represent something that I need the model to understand. But with deep learning, you can just end-to-end. So we input raw data without any further feature engineering, feature extraction they can use, and then you just feed them into a model. After training process, they can show you the results. Okay, so what is the difference? What is the deep learning? So what is the deep learning? The deep learning is a series of consecutive operation for machine learning tasks. 它基本上是一系列的连续的 operation， 就是你连续的 model 的作用。所以在 deep learning, so we call it deep learning is there's several different layers. We call it layers. We'll talk about the model neural network later, but for now you just understand it's a different kind of operations. So we'll have different layers, several different layers. They combine together and they can process consecutively. So it's called deep learning. So it's not necessarily always neural network. It could be a different kind of algorithm if you put them together with a consecutively serious operations they can do together. 好，所以中文上来讲，就是它是一个连续的操作、连续的运算的过程。那它在处理 data 的时候呢，其实最重要的特色是不需要提取特征，特征是 the feature will be extracted hiddenly, so we call it hidden layer. If you do so in machine learning, in deep learning, usually we'll have some neural network applied to it with the input layer. So if we have number 9, we put them into an input layer. Usually they will have several hidden layer. If we put them 2 here, okay, if we put 2 here, this 2 is hidden layer, hidden layers. And we have an output from 0, 1 to 9. Okay, and then they just show you, okay, it's a 9. So they just output, it's 9. So it's a consecutively operation. The hidden layers will do feature extraction for you. Okay, so this is the major difference for machine learning and deep learning. For machine learning, usually you have to find out what is the feature and do feature extraction, feature engineering by yourself, by engineer, by experts. And if you do have those kind of important features already, then you can just think about, you may not need deep learning, you can use machine learning to do so. But if you don't have it, then you can just put this model, put the data into model, and then the model, the algorithm to find out this feature for you. OK， 所以 deep learning 跟 machine learning 最大的区别就是 machine learning 的过程里面，其实你对 data 的处理需要更多的经验、更多的专业，你可能要想办法把 data 的 feature 重要的 feature 找出来，怎么样的 feature 能够表达这一批 data 的特性，这是很重要的哦。那在 deep learning 里面，其实最重要的，它倒不是怎么去找到 feature， 而是怎么样整理好你的 data， 丢进去，找到适合的 algorithm， 可以找到对应的 feature， 然后去做预测。So this is why people always talk about that, the machine learning, or especially for deep learning. Especially for deep learning, they say is interpretable, 就是无法解释的。It's inexplainable, because you don't know what happened inside. It's some people call it a black box. So you don't know what happened inside. You don't know what's going on, what's the decision-making process. How the model, how the algorithm choose these features, we don't know that. We just know how to design and how to use the data and put them into the model and do training. So it should be a lot of experience and a lot of tests before you use this model and jump into the conclusion. OK， 就是在使用任何深度学习模型之前，请你要记得，因为中间有太多东西是不可预期的哦。有可能你做出来的东西是对的，有可能做出来的东西是错的，要怎么判断对错，其实是各位的能力啊。So it relies on your experience, experts, and your domain of knowledge. We call it the DOK, the domain of knowledge. Okay, now I think we should take a break. It's like a 10. Okay, so it's 10:40 now. We're back on 10:55. Okay, so 10:55分回来，好，休息15分钟，谢谢。小猫，你记得关一下静音哈。Okay, so, oh, sorry, it should be here, right? So, 今天下午我要去演讲啊，所以老师穿的，我用中文跟大家闲聊一下。我今天下午要去演讲，我穿的比较像要去结婚一样啊，其实并不是每一次上课都这么慎重啊。对， 那我今天演讲的主题其实是因为我最近其实就最近我其实太忙了，我最近很忙的一件事情是因为我准备要开一间公司所以老师其实一直在这一阵子就是在忙着要成立公司很复杂的很多有的没有的事情，包含政府的规定、学校的规定那学校老师要开公司是一件非常挑战的事情。原因是因为你要符合很多的规定之外，那很多的要求。那我们开公司，老师开公司是因为要做，我们是一个这算是政府资助的一个计划。我们把学校成立的一个之前写的一些专利拿来产品化，然后要做我们就是我的主要的公司的作用就是做生成式 AI 跟增强式学习在 IC 封装的运用以及 IC 封装的设计所以。我们是跟半导体合作，半导体厂合作，所以最近台积电到美国的事情，其实对我们的影响非常的大那为什么呢？其实早期我们其实就觉得啦，台积电迟早有一天会变成被国外企业占领，或是被国外政府很重视的一块。原因就是因为从疫情以后，大家都发现这件事情所以今天我就会分享是怎么样变成就怎么样从学校开始，然后到能够申请成立公司的这个过程那其实这是一个很挑战的一个 process， 我觉得在各个方面来讲都不容易。那所以今天下午我就学校邀请我们去演讲，我去分享一下这个过程其实在美国的时候，在 MIT， 我自己看到的这件事情是非常容易的，就是我那时候跟我们常讲指导教授叫老板跟我老板，我们那时候发明了一个很有趣的一个 AI 工具用来预测蛋白质模型的，那个时候比 AlphaFold 还要早一年，我们比 AlphaFold 还要早一年。那个时候其实美国的药厂就直接来找我们要成立一间公司，所以美国是这样，我老板常常这样子发明了一个新东西，然后呢学校就帮他申请专利，申请完专利以后呢，学校就帮他开一间公司他不用管营运，学校有专门的营运跟 marketing 的人负责帮他，所以整个 MIT 附近基本上都是新创公司跟产业的园区，你可以看到各种的制药厂或者是科技厂 ，Google 的总部就在 MIT，在麻州有一个总部就在 MIT 的地铁站出来就是那个所以看它基本上就这样，我就是你有技术好，你的技术我帮你变成产品，我帮你开公司，然后我老板就把我去的前几年他就赚了钱，把公司卖掉，买了一个酒庄。买一个葡萄酒庄园，所以他名下大概有6、7间公司吧，就每一个技术他就开一间公司，每个技术就开一间公司，一直以来他就是这样。在美国很鼓励这样的事情，是因为如果你只在学术界做这些事情的时候，其实你很容易局限在那这个东西到底可以干嘛？学生也会毕业以后，这个东西到底可以干嘛？我好像进了台积电，进了公司以后，跟我学的所有东西，就大家可能不见得台积电、联发科什么的，学的东西跟我做的硕士论文一点关系都没有。这是常态，这一定是常态。那在美国就不见得是这样，美国的其实在学术跟产业的连接是非常深的所以那时候我从 MIT 回来的时候，我就觉得台湾为什么没有这样的机会，所以我一直努力的在想办法把我们的技术变成专利，专利变成产品的这个过程迈进所以在这几年我们开始有一些成果了。你知道2年前我开始要做这件事情，所有人第一句话见到我，老师是不会成功的啦，教授人工智慧不会赚钱的啦。台湾没有软体公司，很多人是这样跟我讲软体业是不会成功的，在台湾不可能的。去年我要申请的时候，在申请的时候，很多人还是跟我这样讲，但有一件事情改变了。去年在8月的时候，黄仁勋来台湾演讲，大家记得吧？那时候 Computex， 黄仁勋来演讲，演讲完所有人都来找我说，老师，这个该做，生成式 AI 很重要，我们都讲，所以。有的时候其实是时机，有的时候其实是，就我要跟大家讲的是，你现在做的事情，有可能你觉得没有前途，很可能就是 boring， 大家都可能是市场还没有，或是整个环境还没有被 educate 到，可以接受这样的事情。那有的时候是需要一点运气的就是如果黄仁勋没有来演讲，我还得花很多时间来说服大家，甚至是 AI 得做，你必须要做这件事情台湾必须要有自己的软体业，不然我讲难听一点。今天所有的大的软体公司都把握在美国的手上，川普一句话，他有没有机会让这些软体不卖给你？可以的他对中国就是这样他们之前对中国讲，我软体就不卖给你嘛， 我卖给你的是10年前的软体，卖给我们也是假设它某个功能不给你好了，那你有没有办法？所以我们为什么要做自己的事情？为什么要有自己？我鼓励大家，就是你在毕业的时候，不要只想着我就是要去某间公司，然后我这人生是没有稳定100%可以过完一辈子的这种公司就没有，你除非当公务员吧，哦，没有这样的事情。所以你永远是在不断的挑战、不断的学习过程里面去找到自己的定位跟你的价值在哪里哦。有可能我建议通常是你出国去看一下吧，孩子，这个世界很大，在台湾台积电赚的算多，或者是联发科赚的算多，在美国那个不算多啊，在美国可以赚的更多啊。那你去杜拜，那基本上就赚的真的，我不夸张的说，我有一个跟我在美国同时毕业的一个，我们那时候做研究的，他去了阿拉伯联合大公国做研究，他1年的研究经费是我们一整个系的研究经费，一个人的研究经费是我们一整个系所有老师加起来的研究经费，他的出国1年是100万美金的经费，就他出国要去访查或是做实地研究交换，他们整个 group 100万美金，100万美金，我们很难想象这是一个光 for traveling 啊，去建立你的国际地位的一个 funding 啊，所以这个世界很大，很多事情我建议大家出国去看看吧，你毕业完出国去看一下，找机会去外商去哪里走一走，所以英文是很重要的，你要走出去，英文很重要哦。那 anyway, I think it's a very good exercise for you to do. 趁年轻的时候了，年轻的时候你失败的边际效应跟付出的代价其实相对来讲低很多。等到你真的结婚了，或者是你事业到一定的程度了，像我去 MIT 的时候，我那时候已经在公司当到经理了。你要毅然决然的把这个吃掉，你需要有点勇气，你知道吗？会不会回来一无所有？会不会回来你发现你变成基层？这个都要挑战的。所以趁各位年轻的时候，你能够去看看的时候，但是不要去打工，我相信真的，不要去打工游学这种就是。去当廉价劳工的这种做法，我非常的不欣赏，因为你累积不了任何对你人生未来帮助的经历。Right, so, if this is like a resume for you, what do you like to lead the track on that? 就是你在你的履历上面，你想留下什么样的记录？你觉得对你人生未来会有帮助 ？OK, so, just think further. 我对各位的期待就是想远一点啊，你们不会只是一个工程师。You should be a manager. You should be someone that can change something. Okay, to be innovative. 更有创意一点的一个工程师也好，或是人才也好。OK， 台湾最值得骄傲的就是我们平时培养出很多很厉害的人才，只是大家对自己好像都没有那么有信心啊。So be confident about yourself and just go out and to see the world. The world is so big. It's a lot of possibility. OK。好，那其实台湾有很多可以出去的机会，不见得是你要自己花钱。So try to just try to apply for that. We got 我们有很多的出国留学的奖学金、交换的奖学金，甚至就是真的，你觉得你可能觉得在这个世界里面还有很多你想去尝试的。我每年会给自己一个挑战，像我今年的挑战就除了开公司那不算挑战，那是一个工作。我给自己的挑战是我要去考潜水教练，我非常喜欢潜水。那这个是一个我可以不用带手，就是不需要被手机绑住，跟外界完全没有任何联系，你就在水里就是自己。你可以，我以前在没有潜水之前，其实我很喜欢去水族馆。我不知道各位同学有没有这样的习惯？我只要心情不好或是压力很大的时候，我就会去水族馆看看鱼，觉得是一个非常舒压、非常 soothing， 然后非常能够让你冷静下来、好好想事情的一个地方。在台湾的水族馆其实并不好找，这最近的要跑到车城的海参馆，对吧？我记得好像高雄应该没有水族馆吧，好像最近的在海参馆啊。台北好像在桃园有一个。那我那时候在 Boston 的时候，其实 Boston 的水族馆在港边，所以其实我搭地铁就可以到。有没有人看过 Aquaman？Anyone watch it？ Aquaman 在第一幕的时候，就开始没多久的时候，那个小男生站在一个鲨鱼的水缸，一个很高的那个水缸。This is the Boston Aquarium， 那个就是波士顿的水族馆。之前我很常站在那里，然后看着，就是问题想不出来，觉得哎呀，为什么我周遭的人都是这么厉害的变态？ 自己去那边觉得自己压力很大，是个废渣的时候，你就会跑到水族馆去。所以后来回台湾以后，我去学潜水。那在水里面，其实你就会发现海里面不是水里面，在海里面你可以感受到一种，因为真的没有什么声音，然后是很平静的，你是没有重力的状态下。各位如果年轻的时候，你们可以去试试看。年轻的时候可以挑战自由潜水，像我这个年纪，我觉得不行，因为我们一口气上不来，就真的回不来哈，不出意外就出意外的这状态啊。那年轻的时候可以挑战自由潜水，是因为拍照好看。我真的自由潜水的拍照起来真的是比scuba diving 好看很多。那各位要记得在自己的能力限度内、身体限度内去做挑战啊。自由潜水是一个很不错的，因为带的器材很少，你就带个呼吸管、面镜。穿个水母衣、比基尼就可以下去了哦，那是非常非常酷的一个体验。我每次在看到潜水车，就是我们就背着大包小包像去行军，好，那自由潜水的人就是我有一个学弟在 MIT 毕业的，他是 MIT Computer Science 毕业的，那自己开公司，他也在跟我一起潜水的，他在学free diving 跟 scuba diving 同时学，那他现在在挑战自由潜水，就是说。他就跟我说，他趁年轻的时候，他体力还行，要去挑战自由潜水。那每年我都给自己任务，今年我就是要考到教练的执照，潜水教练的执照。所以这并不见得我并不是我要去教，而是我给自己立下一个挑战，就是说我今年要做到某些事情啊，除了工作以外的挑战，我每年会给自己一个不一样的挑战。像有一年，我之前就有一年，我跟自己讲，我要学做菜，或者是学做什么料理，哪一个菜系的料理。有的时候你就会学做糕点哈。有的时候你会学一种新的语言哦，就每个人可以有不一样的挑战。每年你给自己一个新的挑战的时候，其实在生活之外，你会有一个不错的调剂，你会让自己更有动力去做这些事情。好，那建议大家真的毕业以后出国去走走啊，看一下这个世界到底有什么好玩的地方啊。Okay, so we'll go back to deep learning. So, this is a question here, the Q question. So I would in this lecture note or the textbook, I would use this kind of box. 其实我以前这个是用 latex 打的，有同学会用 latex 吗 ？Anyone use latex? Latex is very good. Like a program, it's like a programming language for the like a document formatting and editing. It's kind of a geek. 就早期的没有 Word 那么好用之前，大家都用这个。现在我不用这个，原因是因为我学生不会用，所以每次我要改他们文章，如果用这个，等于是我在帮他改就算了哈。所以后来我还是用 Word。But in textbook， 最近因为刚好我要写 textbook， 我不可能叫学生帮我写 textbook， 我就又回来用 latex 啊。So I use back to latex。latex 最厉害的地方就是它可以很简单的使用这些 box。知道的，其实你在 Word 要设定这个非常的痛苦，在这里你只要在一开始设定好，然后就可以用，非常的简单，非常的简洁。那每一次到固定的地方，并且你看，如果你们翻到后面你们翻到后面来，这里可以显示程式码，它这个不是截图哦，这个是文字可编辑的哦，这可以显示程式码，并且有 syntax， 有没有发现哦？它跟你的那个 syntax， 所以 latex 非常的好用啊。如果各位同学有兴趣的话，你以后要成为一个专业的工程师，其实学会 latex 会帮你省很多事情。OK， 如果你要跟人家合作了，那 latex 不见得是一个好的工具，因为大部分的90%以上的人是不会用这个的。OK, good. So let's go back to the lecture. So in this lecture notes, you can always find a box here. I will leave you some questions to make you think, and I will give you some answers. But this answer is not the only answer. This answer is my opinion. OK， 就是我对这个问题的看法，我的答案是这样子。通常是有的是 paper 的，有的是文章里面揭露出来的内容。那经过我修饰以后变这样。那我必须要讲一个重点，就是这个不见 ，it is not always the guideline or the Bible for this. This is just for now. The answer is maybe somehow correct or somehow reflect the truth of the domain recently. It's gonna be changed like really fast. 有可能这一学期讲的，下学期就错了啊，在现在教 machine learning, this is the trends of machine learning. Recently, it's changing every day. So maybe it's correct now, but maybe it's incorrect. It will be incorrect next semester. I don't know, but so be cautious. I just show you the possibility or some certain reasons why we like to ask this question. So why is data considered the fundamental field for intelligent system in machine learning? So the data is fundamental field because it embodies the raw information from which patterns, trends, and insights are derived. Okay, so this is what we are looking for: patterns, trends, and insights. Okay, for this kind of information that we like you that you need to extract from data is the patterns. Maybe to find out patterns. What is the patterns? This kind of patterns we call hidden patterns. What is the hidden pattern from that? They get the certain rules, but it's not explicitly, you can write it down, so it's patterns. Or trends, it goes up, goes down. It's possible. Okay. And insights, what can these kind of data make you think more? To bring more information, to bring more valuable ideas from that, it's called insights. So without high quality, remember, the data is not about the amount. You can easily get a large amount of data. So you can record, maybe record the temperature every second, right? Temperature change every second. 你可以就是把温度变化每秒都记下来，或是千分之一秒记下来，你随时就有成千上万笔的 data。But can you get more information from the data? Can you get more insight from the data? I think it's not necessary, right? It's not correlated to the data, the amount of data, because maybe the temperature, the difference for temperature is gradually changed, I think, for the high ambient temperature. So for the room temperature, for what your environment. So the seconds to the milliseconds, it's not necessarily need for this kind of observations, maybe hours perhaps. So the amount of data is not the most important thing. It's the quality of data. So we need high quality of data. So that's what we talk about. In your domain, how do you define high quality data? It requires your knowledge, the domain knowledge. What is your expert? This helps you to understand what is the quality of data. Is that data good or not? Is the data meet the requirement of our model? Is this data necessary? Is this just noise? Okay, so somehow you need to understand how to collect data, how to obtain data, and how to select data is based on your expertise. Okay, representative data. So that's what we say, representative data. Okay. Okay, we got a representative data. Good. So the performance of any machine learning model is intrinsically tied to the quality and also the quantity of the data it is trained on. In addition, in today's interconnected world, we got internet, ability to process and analyze it, distinguish cutting-edge AI system. Okay, so the cutting-edge data can analyze and process diverse data and larger amount of data. Okay. So for machine learning model, we got two types of model. The first type of model is classical statistical model. We got naive Bayes. We got Boltzmann machine for that. And the state-of-the-art deep learning. We'll talk about deep learning model later. Okay, this stage is the insight of distill into actionable output to show you how to do it. So from that, I think here, the question is, how has the transition from traditional machine learning to deep learning impact the way intelligent systems are developed and deployed? So the difference from machine learning to deep learning, I showed you before. I summarized it in the class is without feature engineering, right? You can put the raw data into the deep learning model and find out the hidden pattern and hidden features and do some regression and classification tasks for you. So the first thing is the deep learning, the transition brought about several key changes. Automatic feature learning. The feature is learning by a hidden layer. So if someone asks you what is the difference from deep learning and machine learning, the first one is the most important feature, the automatic feature extraction, feature learning, without explicitly feature engineering. Okay, so you don't have to find out features. Just put raw data into model. The model will help you to find out what is the important features or what is the features they're looking for. The deep learning model automatically extract. So automatically extract hierarchical. Importantly, hierarchical. Hierarchical 这个英文的中文叫阶层式的。Hierarchical features from raw data, reducing the reliance on manual feature engineering. 早期你真的就是人工要去做。So what is the hierarchical feature means? I will show you later. And end-to-end training. So from data to results, from end-to-end prediction, from data to what's going to happen, it's called end-to-end. Okay. So in MBA, we'll go coast to coast. Coast to coast, which means 就从东岸到西岸，他们叫 coast to coast， 其实就是指从底线拿了球直接快攻得分，叫 coast to coast。在美国很常用这样的用法，什么A to B。So end to end, from 第一个 end 就是 data end to the other end is the result. So we call it end to end prediction. Okay. And then we have the enhanced performance. What is the ability to process large-scale unstructured data, especially for unstructured data? The deep learning model achieves superior performance in complex tasks, image and speech recognitions, natural language processing, and they can do rapid iteration. The use of flexible framework, you can easily find out different frameworks for machine learning and deep learning, especially for deep learning. We got abundant pre-trained models you can use now. And broader application, deep learning has changed everywhere, have changed all your work, your cell phone, Google, and everything now with the AI embedded inside the system. So your work is now, I think, fueled by data and empowered by deep learning model. Okay. So, but I have to mention here the ethical consideration. The ethical consideration is the important thing for using AI. Because now you have the large language model, LLM, and AI writing system with you like GPT. So, what is the importance of ethic consideration if this is not your idea, this is not what you saw, it's generated by AI, then you should mention it. Okay, this is the ethic statement that you have to put into everything, your report, your homework, and make some good examples that from everything that you understand. Okay, let me show you some example. One day I'd like to submit a journal, a draft to a journal. Then the journal just appeared, a box that led you to make a statement that some part of your work is generated by generative AI. And so it's a requirement that you make the statement. So if they detect some part of your article, your draft was being generated by GPT or some other generative model, then you'll be rejected without any reason, just because you make unethical statement. 就是说你现在投稿的时候，他就会要求你去确认你是不是用生成式 AI 写，如果是，请写明哪些片段。好，那如果是修改的话，你用生成式 AI 帮你修改是 OK 的，那你要写清楚你用来做什么，但你不能都不写。如果都不写， 然后直接被投稿的系统抓到，你会直接被退稿，并且现在投稿系统是共通的哦，它的比如说同一个出版社投稿系统是共通的，你在这里被退的原因是因为这样子，你下一篇没有写，会直接被退哦。所以之前就有老师被这样被直接被退过了哦。所以就各位如果都是研究生，老师要求你们要投稿的时候，请记得，如果你用 GPT 写的，一定要讲清楚哪个部分是用 GPT 写的，是用来修改还是全部用 GPT 产生的。因为这个会被退稿的，这个是直接会被退稿的，请大家记得。好，那现在侦测的系统越来越严，那你说他有可能真的说，其实对于主编来讲，只要有这点疑虑在，那他宁可不要，因为每天要投稿他的期刊那么多，对不对？好，所以请记得，这是非常重要，对研究生来讲，这是一个非常重要的观念哦。如果你有用，一定要让你的指导教授知道。你写在哪些篇章，或是用来修改，你可以说我写完以后写成中文翻成英文，然后修改，这样其实都 OK。但是你如果都不讲，到时候就是被系统侦测到，直接被退稿，这是很亏的，因为你接下来会很难投相关的出版社的期刊。好，只要是同一个文章的话，它直接都会有记录了。OK， 好 ，Good，let's go back. So we'll talk about several types of learning. Okay, we got I need a new. So for machine learning, we have several different types of learning. The first one is called supervised learning. The supervised learning is based on label data. So like this, if this is the number of 5, so we ask some people that show you, is this a bike? What is the number of this? Then you will say 5. So they report it, and so the they will show you, they will put them into a folder. The folder is 5. They get several different handwriting images. They belong to this category. They just put them into the folder like this. So it's called labeled data. So usually the label data is handwriting, is human effort, labor effort, and manually do labeling. So label data is difficult. Label data is time consuming. Label data is very costly. Okay. So you do, sometimes you hope people are doing labeling, you just don't know that. So if you browsing some website, the Google will show you that try to identify, are you a human being, right? So they will have you some like this one, and select the traffic light, maybe select where's the bike. So you are doing the labeling for them, automatic labeling. 所以他就一开始你进网页的时候，他会问你说确认你是不是真人嘛，对不对？然后请选出红绿灯的位置，对吧？啊，请选出底下所有有机车的照片，对吧？你其实就在帮他做 labeling。So this is another way to do labeling that Google asks you to help them. So which means the label data is really costly, really costly. It's 非常的贵 and really time consuming. It take a lot of time, take a lot of people to doing so. So data is easily to obtain, but label data with proper label is another thing that you need additional time. You need something that is unrelated to what you have been working on. So it's just labor effort. You need to do it by yourself, by human, or you need some part-time, maybe some part-time interns for you to work on that. Okay, so this is what we do. This is label data. Okay, good. So you use label data. So what is supervised learning? In supervised learning, first of all, we'll have a model. We have a model here. And then here's input. The inputs, the model will make prediction. Okay, so this is the first. The model will make prediction. Then you have to compare we have to compare the prediction from label. Okay, so they have to compare this, compare the prediction with labels, and to see what's the difference, what is the major distance from both of them. So the prediction and labels, they will have different kind of a different kind of measurements. We'll show you later. We call it loss function. We have a loss function to do so. So in this part, we'll have loss function. And then the loss function will show you some, maybe the trends of how to evolve, improve the predictions. So then we'll go back to the model and make the new predictions and then do it again iteratively. So this process we call training. Okay, understand? So for supervised learning, we just put the input and then make prediction without any further without any further transitions or alternatives. Then we compare the predictions with labels. So in this part, we call it use the loss function to do so. The loss function gonna show you how close your prediction to the labels. Then we'll have to do iteratively to find out how to update our model to find out the best way to do so. And then this is the training process. This is what we call training. Is that good? Okay. Then what is the purpose of training and how to train and what to train is. So the first one is what to train. The first is what to train. So we think about that. We got the predictions y is equal to a function of inputs. We call it xi. This is we call input. And this is predictive value. So this h, we call it hypothesis or the model, or the model now. Hypothesis or the model. There are several different models you can choose, like a random forest, like a tree, like a knife base, or different kind of like a boost, several different kind of hypotheses you can choose. So what's the, so hypothesis you can think about just a function. So the function that we use to do something like this is Taylor series before. So we do Taylor series like y is equal to f of x, I is equal to c1 x plus c2 x2 plus c3 x3, something like this, right? So the x1, x2, and x3 is input, so it's known. It's already known because you put them into the model, so it's known. It's not unknown. Okay, x is known. So what is unknown? What is unknown parameter? So for this model, the unknown parameter is C1, C2, C3, right? C1, C2, C3 is our unknown. So this is unknown parameter. This is the unknown parameters that you like to obtain. Okay, so how to solve it? It's based on training. Okay, but we'll have more different kind of a type of depth. So you can use like a linear, we can use a linear projections. So it's y is equal to wx 1 plus b. So this is weight. This is the weight function, the weight parameter. This is the bias or the shifting. So now let me show you graphically. So which means it's gonna be linear, right? It's gonna be linear, something like this. It's gonna be linear process, linear. So the weight is the slope. Here, weight is the slope. The weight is the slope. And the bias is when x equals 0, so this is b, and the slope is w, like this. Okay. So if we do the linear approximation that you can find out, is something you need two parameters. One is the intersections or the bias. The other one is the weight. So you can use a different kind of several inputs or several different kind of orders. You can do that non-linearly, the second order, third order, or lots of different kind of nonlinear functions to do so. So basically, we try to find out what is the weight and what is the bias. So the training process is to determine the weight W and the bias, to determine this, both of this, the weight and bias. So training process, how to do it, and I will show you later. So this is the fundamental of machine learning. What is the learning process is for supervised learning. The example now is for the supervised learning. So you do know the answer. I know the answer, but I don't know the rule. I don't know. I don't know how to distinguish them by rule, by explicit rule. So I know the hidden pattern. I know the hidden trend. So I provide those labels, and could this model help me to find out what is the hidden pattern, what is the hidden rule, what is the hidden trend for that? Okay, so this is the training process. Any questions from the training process for now? Good. Then we will have something that is related to the ideas of what we do. The idea of what we do is to find out. This is y label minus y. This is a predict. This is a predict. This is label. Then we take absolutely value to find out the distance, and then we put a square to them. And then you can summarize them, how many inputs, and divide by n, that we call mean square error. This is mean square error. Mean square error function. This is the typical type to measure the difference from your data and predict label and predict data. So this is we so-called MSE. So you can do several different kind of loss function. We got this is for regression. For regression, or you can use it for label data. It's also fine. But sometimes you can use categorical loss, like so there are several different kinds of loss function that you can try. Maybe some people will use cross entropy, or binary cross entropy, or multi cross entropy that you can use. Okay. Any question? Good. Then once we have this value, then you can do how to find out how to update it. We use the algorithm. We try to optimize. Try to find out the augmented minimum that and y label plus y square. We try to minimize this. So it's called argumentally minimize the MSE function. Okay? And so how to do it? Then we'll have an algorithm called gradient descent. Okay, we'll talk about the gradient descent method later. And also we'll help you to implement it. Okay, later. Then we use the gradient descent method to update weight and bias.我觉得好，这边要讲一个重点啊，我中文解释一下。这边讲一个重点是，其实它就是在，反正你模型不管参数怎么选，它都会有个答案嘛，对不对？你只要参数对，丢进去都会有答案。这答案猜的准不准，其实是要经过训练的，它会越猜越准。如果你的演算法是对的话，所以通常我们在怎么让演算法越猜越准，就是你想办法，我们换一个方式想，就是想办法让这个值越来越小嘛。当这个值越小，小到是0的时候，它基本上就猜的完全一样，一模一样嘛，对不对？所以这个值尽量越小越好，这个误差的值越小越好。So we try to find out the argumented minimum value of the mean square or of the loss function. Here, this is the loss function. This is the loss function. Okay. So we use gradient descent. I will show you the details of the gradient descent. The classification problem show you here. Okay. And let me show you. Okay, here. Here's the thing. Now we have several different tasks you can choose, and this is logistic regression. Okay. So the logistic regression is y is equal to 1, and so the overall probability, and the x equal to this. So this is the probability function that we try to do is from here. So if we get the possibility larger than 0.5, we belongs to 1, and otherwise we classify it to 0. 这个是分类的用法哦。那we call it sigmoid function. 就是你在分类的时候，它可以把它分成这样子啊，这个是模型啊，这个是一个 model. This is another hypothesis. We will show you later. Okay. Then we'll talk about this later. Good. Let's have the showcasing of the code. Good. 好，老师会带着大家做一遍哈。所以大家如果没有写过程式，就是没有写过这程式，没关系，我们一步一步来，大家慢慢做哈。好 ，OK。那我先把这关起来。OK，so 我喜欢这样子开 Jupyter Note， 我喜欢这样子开 Jupyter Lab 或 Jupyter Notebook， 大家有各自喜欢的 IDE 的方式，大家自己习惯哈。就是你看我都会把这个调成这个样子，就是绿色的这个哈，很像骇客任务。有看过骇客任务的电影吗？看过的这个年纪都有一定的水准了哈。就是 the matrix 它基本上就是密密麻麻的那个，就是那是一个当年非常有名的电影，它就是密密麻麻的绿色的字哈。那好像电脑就感觉自己很厉害，所以从那个年代开始，老师就有这样use it. So let's do it. We need to go to the document to see. I got the lecture, CD lecture. Deep learning. This lecture is deep learning. Okay, so I can use it in here. Okay, good. See deep learning. Good. Okay, so let's do it. Let's do Jupyter Lab here. Jupyter Lab. 如果你是 Jupyter Notebook， 你就打 Jupyter Notebook， 它应该是会跳出来。Okay, so you can see it here now. Good. 哦，不是这个，好，我们要这个是之后的课会用的，好。Save. Okay. Using Python 3. 好，我把这个关掉。好，大家就自己开一个 Python 3，好。好，一开始我们会所有的 Python， so in Python programming, the most useful or most handy way to do so is use someone else's code. So they already developed this kind of model, the module that you can use. So today we're going to use scikit-learn, scientific learning, for a scientific toolkit for machine learning. So it's called scikit-learn. So the way to do it is you need to install it, or maybe using PIP or something somewhere to install it. But if you have any questions, you can reach out to TA. TA will help you. But for now, I think anyone who haven't installed the Jupyter Lab or any Python IDE in your environment, should you raise your hand? 还没有安装 Python 写程式，应该有吧？因为你考小考了嘛，对不对？哦，那还没有装 scikit-learn 的，回去记得要装一下哈，或者是 PyTorch 记得回去要装一下。So please install scikit-learn and PyTorch. I will show you today. So let's do it. So the model, there are several ways you can import the modules into your code. The first one is from somewhere import something, or you can import directly scikit-learn. But there's a difference from that. If you import everything into your model, if someday you like to just make a package for your code or for your pre-trained model, they will be humongously because everything been included in your project. So somehow we just use some function that we need. So you just from somewhere import the function that you need, then it's necessary. Then it's enough. So today we're gonna show you this way. So it's from sklearn. sklearn. So you can use it sklearn model. The dataset. sklearn the datasets. Import. Load. Rest. Okay. So this is a dataset that you can just download it from this. So this is a function from the sklearn dataset. They got the function code that select all the breast cancer data from you, for you. And then I will show you what is the possible way to do training and to do machine learning training. So you need to train, but for this next module, we'll use it to help you to shuffle in your data set and then split them into training and testing. I would tell you what is the purpose of a training and testing, but we just do it. We just do it now. So you can do it from sklearn, the model selection, import, train, test split. Okay. And today we'll use linear model, just to use a linear model. So from sklearn, dot linear model import. There are several linear models you can use. We use logistic regression. And then we can do some metrics. We need the metrics to evaluate your model. So this we call metrics. So sklearn metrics import. Then we import something accuracy score. This is accuracy, and also you can add precision score, and you can do it with recall. I will tell you the difference, and the F1 score and the ROC AUC score. Sorry. Okay. So after that, you can just type the Control Enter or Shift Enter. You can use Shift Enter. Then you can see there is a 1 here. So which means you already import all this function, necessary function into your code, into your project. Then you can start working on that. I'll give you some, give you a few minutes to finish this. Just this is our first live coding, so I'll text. You can take some time to get familiar with this, and then you can use tab. If you typing something, use tab. They will automatically make a addendum for you. So you don't have to type them. No, just use several key maybe alphabets. Then they will just you hit the tab key, and then the IDE, we call it Jupyter Lab, will help you to finish all these words or sentence. That will be very handy. Okay, use this kind of approaches. Then we have to load the data. So just have this good habit. Always leave a comment for what you're doing. So for now we would like to load the data set from low breast cancer data. Low breast cancer this function. So we'll just leave a comment. So that we'll load the data set, the breast cancer data set from. This is a binary data set. They show you that is or not. Is it classification? Okay. So we have X represents the feature, Y represents the label, and you can use the low breast cancer and return equals to true. So if you'd like to see what's inside, you can print X to see. So it's some features like this. 对，非常。Okay, now we split it. So usually we do training and testing. So the training testing split it's ordinary. It's a typical way that we do try to avoid model for overfitting. I will talk about overfitting next lecture. So today we'll just use it and then let you get familiar with this kind of process. Okay. So now we split the training and test. So you can do the split, the data set into training and testing. Like usually we'll do 82 split it 80-20, the 80% for training or 20% for testing. Oh, you can do 75% to 25%, 3-1. So you can do like 75% for training, 25% for testing. Some people you use 9-1, so 90% for training, 10% for testing. The reason is because it relies on the amount of data and the quality of data. It depends on the training performance. So if your training performance is relies on the data, the number of data, and then there will be some the amount of order the data set you can obtain. So if you have a huge amount of data, you can do 90-10, or otherwise I would suggest you to do the 4-1, like a 80-20 or 75-25, usually for your scientific research project. Okay, so here we do the 80-20 split. So now you can use the function to do so. The function will split the data set into training, also the label into training and testing. So they will return something. They will return four arrays for you. One is for the feature training, feature for testing, label for training, label for testing. So they can return 4 things for you. So this first one is X test, X train. And the second one is X test. Third is Y train. The fourth one is Y test. Equals to. Then use this function train test split. Then we put. So what is the one to be split? It's your training set, right? The training set and the label. The training set is X, and Y is your label. And how to split them? You need to let them know the test size. Use this keyword we call test size equals to 0.2, which means here. The 0.2 is the 80-20. Just let them know. And you need to record the random state, because if you do not record it, every time they will be different. So use a random state or random state. We call it random state equal to 42 or 23. It depends on you. In our lecture, I use 42, but you can change it to the number you like. Okay, it's a random number. The random state, they use it for shuffling. So they will shuffle your data. It's not by the original order. They were shuffling it. Once they shuffle it, then you can find out, okay, this kind of shuffle or the different shuffle, the performance is quite different. Then you will have a big trouble with your data. So you may need to increase or improve the quality of your data. OK。Sorry about that。等我。没事。我大概1:30左右会到，我现在在上课。喂，我现在在上课，我晚一点回你啊。喂，1:30左右会到，我现在在上课，好，我等等回你。Okay, now we have done all the data processing now. So the next one is to select your hypothesis, right? Select the hypothesis, which means select your model. So the model we use now is for linear model and the logistic regression for the classification. So the model is used this way. So we create and train the logistic model. So now let's create a model. Create a model. So create a model is just use model equals to logistic regression. And in logistic regressions, usually they would require how many times you like to train the model. So we can put them like 1,000 times. So the max iterate equals to maybe 1,000. But for now, you can just do 100 for that. For the sake of time, you can do 1,000. Okay. And then you train the model. We can train. Now we train the model. So how to train it? We use a function called fit. Okay, so we use a function called fit. And then what is necessary to input for the model to train is your X training, right? The data set for training is called X train. And then also you need to provide, because it's supervised learning, you need to provide the label. So what is the label? We call Y train, right? So you need to provide this too. So it's model, the fit. And then it's called X train and Y train. This two. Fail to converge. Okay. Whoa. Let's do it. Okay. Good. You can see the result. 1000步竟然收敛不了，这模型有这么烂吗 ？Okay, I use 1,000. It's not converged, so you can increase the number of maximum iteration. That they may require more time to converge. Okay. 那助教，你们昨天测试1000步是收敛的吗？我看你们测试的结果，你们1000步是可以跑的，是收敛的结果嘛，对吧？对 ，OK, but yeah. But you can test it. Anyone try with 1,000 iteration? It's converged or not? Okay. Any questions? No. 有没有人测试过小于1万步的1000步有没有收敛？
你们执行不收敛吗？还是可以跑？不能跑。你们呢？可以跑，1000步也不行。那10000步了？对，10000步可以。所以，助教昨天测试1000步 OK，因为我之前跑1000步是可以的。对，可能我觉得是电脑的因为我那时候是用我们的工作站，但是它这个也没有用到 GPU 啊。But anyway, I don't know. But yeah，就是准确度有差，所以那时候我跑1000步，好像不到1000步就跑完了，所以我有点压抑。But anyway, you can change your maximum iteration to find out the acceptable result. After that, you need to predict. It's not about use it just for testing. We need to predict the result. Okay. So you can do predict. Now let's predict the results. Okay, now that we predict, so you got y predict is equal to model. We use this, it's called model predict. Then put the y test. We put the x test inside. We also need the probability that predicts. So we'll show you let's obtain. Sometimes you may need the probability of how they distinguish this data from 0 to 1, from one class to the other class. That may need we need some guidelines for the probability. So they will show you the probability of confidence. How confidence I think this one belongs to the category 0 or category 1 or the positive or the negative. So sometimes it requires some several techniques to check, and then we'll use usually with like accuracy, position recall, and F1 score, and also show you the ROC. Okay. Good. So for now, we have to obtain the probability. Probabilities for the testing. So y PRO probabilities equals to model, then predict probabilities for X test. And then we only need the first row, so we use this as a result. For this one, we just use the first row. So the first column, first row, sorry, row column. So the first column, they will show you the second column. It's not first column. So Python is starting from 0. So if you see the number 1, which means the second, okay. So we only need a second column for that. I will explain more details later, but so let's keep moving. So now we have to evaluate the performance of your model. So the performance of your model is, we use some score. It's called accuracy. Accuracy is equal to accuracy score. It's a function. It takes your y test. It's a label and your predict result. Then you can print accuracy is equals to so we reach like a 95% of the accuracy. So it's really good, right? It's really good. The testing result is good.
Okay, everyone down? So what is your accuracy? It's about 95% or 96%, right? 有没有人算出来的准确率不一样的？它的准确率大概都多少？ So what is your accuracy? What is your accuracy? You done? 95%. Anyone? Same. Okay. Good. Good. So what is your accuracy for both of you? The accuracy? 你们两位的准确度大概是多少？就差不多嘛。So it should be the same number, right? Because you use the same. In this model, logistic regression, linear model, if you use the same random state, they should be pretty much similar, the same result for that. Okay, good. So this is the first one. I will show you some. Now we'll show you some regression. Okay, I will show you some example for regression. Let me just file. Rename classification. Okay, I will show you next one. We use a regression, demo regression. Also use scikit-learn only. Then we'll revisit the results using a deep learning model. So I have to mention that something is important. Something is important for that. That is, some model, some data is not necessarily using deep learning. Some model is good for predictions, especially for medical application, healthcare application. I want to participate in a project that called dengue fever classification. During the COVID hour, I don't know if we have the experience, but usually the summertime is the rock time for like a very hot zone for dengue fever in southern Taiwan, especially Tainan, Kaohsiung, Pingtung, several different counties that you will have the severe dengue fever everywhere. So in Tainan city, they will just display the alarm of where is the dengue. Somehow in NCKU campus, always the hot zone for dengue fever. So one day the physician came to me say that could we have an AI model to distinguish some severe symptom with a mild symptom for the dengue fever? Because you know the leakage of the shortage of the laborers in the healthcare center, they're always a problem for them, especially for emergency. So is there any possibility they can use this kind of AI model to predict? So predict based on what?
Dengue.
So we try to get them some triage symptom. So the triage symptom is when you go into when you're just entering this emergency center, that there may be a nurse or some physicians would go to you, say, how do you feel, any symptoms? Then you tell them that I feel fever, nauseous, or dizziness, and some I feel illness, something like this. So they will just click on the iPad, and then they will show you pop up like a possibility of dengue or dengue severe symptom. Okay, so based on this guy, based on what kind of rule that the doctors or nurse can make a judgment call is if this one is a severe symptom, then I need to take care of them, this kind of a patient first. So it's based on some the rules they need to follow, but it's really difficult to use triage symptom to do so. But in this kind of case, if you use deep learning model, it's impossible to explain how this model distinguishes the severe symptom to the mild symptom, right? So you cannot explain to your patients that you have to wait because the AI model say that you are not severe, right? You cannot say that. They're gonna sue you, right? Or they're gonna hit you even worse. So So the best way to do it is use the logistic model. So this kind of model, machine learning model that we use like this, because this model, this model we use can show you the probability, how likely this patient is severe, how likely this patient is mild. So you can use this probability as a guideline to show, oh, you got 95% become a severe symptom, so I have to take care of you first. You got only 5% of severe symptoms, so you can wait for a while, then we'll take care of you later. Something like this. You've got the probability for physicians or doctors to have to make the judgment call. Okay. And then we'll go to another one. We call it the regression. So this one is called regression. And in regression, we'll use a different kind of data set. So the data set is diabetes. So diabetes is another major comorbidity for Taiwanese people. Once we have like the elderly become the elderly society, the social impact with this kind of society is you need to pay more attention to those who may be healthy, maybe not healthy for the elderlies, or we call the senior citizens. So it's important. So the four most comorbidity with 就是我们讲共病，就是说你的慢性病 chronic disease 这些的很多人有的是包含 diabetes。第一个 diabetes 就是糖尿病 ，and hypertension we call 高血压 ，and or CKD it's called chronic kidney disease。CKD is for 肾脏病在台湾其实很好发的心脏病。再来可能是心脏病心脏方面的心血管方面的疾病。So we got this kind of comorbidity. Comorbidity 就是称为共病就是说你通常不会是只有这个疾病，你会有好几种疾病，但最常见的伴随的慢性病就是我刚刚讲的这4种Okay, so diabetes is one of the most important or most common comorbidity in Taiwan. The next one is CKD and hypertension。台湾其实肾脏病有的人非常的多，比你想象中的多非常多。那这个跟生活习惯有非常大的关系好 ，OK, so let's do it. Let's low modulus and do the same thing. So here, let's low modulus. Let's low modulus. The first one is from sklearn again. sklearn and dataset import low diabetes. Here we got low diabetes. And also from sklearn for model selection, import trend test billet. Also from sklearn linear model, another linear model, import linear regression. So you can, from sklearn, we'd like to also some metrics, right? METIC metrics, import. We need two. One is the mean square error, is the loss function, and the other one is the R2 score to evaluate the accuracy. Okay, so we got the mean square error, and the R2 score for evaluate the accuracy. Okay, that's all. And also forget, we need to import NumPy. Now we need NumPy. Okay, import py. So we import NumPy as NP. So this is usually we do. We import a whole package. So we'll give him maybe a nickname. Okay, 你就给他一个缩写你给他一个缩写，那这个缩写就是 SNP 那有的人很讨厌，他故意这里会乱写，比如说这里 STF 那就明明 TF 是 TensorFlow， 他就一定要 NumPy， 这个就会让人家很生气NumPy。Okay. Okay, so the first thing is load the data set. We will follow the same procedure. not here. We're following the same procedures doing here. So we're gonna load the data set and split the data set and create a model, train a model, and see the performance. Okay, that's like the 3-step of your machine learning model. Usually like doing this. You can change your model with a different kind of model, the random forest, something else. We all following the same procedures. The first one is processing data, create a model, train the model, and then see the result, the prediction. That's all. Okay, so now we can load the data set. Oh, sorry. So this thing is, first one is load the data set. Load the data set, we got the X and Y. X, Y equals to low diabetes. Low diabetes. And return. Okay.
是分享画面跑了。
分享画面跑了。哦，它断掉了，是不是 ？Sorry。
对。
现在可以哈。Okay. Okay, good. Good. Hey, what happened? OK 了吗 ？OK, good. 好，各位同学，来，请看。接下来，我们 split it into training and testing. So we got X test, X train, Y test. Oh, sorry, X train. Sorry, it should be X train first. Y X test. Y train and Y test, right? Equals to train test billet with X and Y, and test size equals to 0.2. And your random state, let's change it to 23. Okay. Okay, let's do this. Use the tab wisely so you can hear the tab key. Once you type a few alphabets, 就你打几个字以后按 tab， 其实这个编译器这个 IDE 啊，它会自动帮你把后面的字补完。如果你打对的话，那包含我们出现过的变数也可以。假设你看啊，你这样，你随便打一个 XTR， 然后你按一下 tab， 它就自己会跑出 X train 哦，这个蛮方便的。Okay, just use the hit the key to do so. And then for the next one, we should create a model and train a model, right? So we create a model and train a model, do it at the same time. So I will do it to show you how to do it. So let's do train, create, and train a linear model. So the model is equal to linear regression, and that's all. They don't have to put an additional argument. And train the model. Model the fit. You can fit them into, so they got the X train and Y train. There you go. So you got a model, the linear regression model is done. Then you can do we can do predict the result. So you got the y predict equals to model the predict x test show the matrix. So we'll do the R2 score. Sorry, we'll do the R2 score. R2 is equal to the R2 score of y test and x test and y predict. So now you can print the R score is equals to R2, and it's all. So this is your R square, okay? Okay, for this R square, it's not a very good. It's not a very good result. I have to say, this is not very good. The reason why we use it to show you that is, this is just a linear model. The limitation of linear model is always like this. If your data is really simple, you can find out, then use it, and that will be easier. But you can see that the same task, we found breast cancer to the diabetes. The result, the significant results from previous is 95 to 96% of accuracy, but for here it's only 45, right? The reason why is this kind of regression requires more nonlinearity that you need to introduce. So if you goes to regression problem and you choose a very simple model like regression, this always gonna happen. Okay, so what can you do? The reason we can do the things that the actions we can take is, the first one is to try to simplify your data. The first one, simplify your data. Try to find out only key feature to the result. This is the first thing, but it's really difficult to find out. So the second thing is transform this, select another hypothesis, find a new model, more complicated, more nonlinearity inside that you can use. Okay. So I will summarize this lecture. So today we mentioned what is the artificial intelligence and its definition, what is machine learning, and what is the major difference from machine learning to artificial intelligence. I show you some cases, some implemented cases, live coding with regressions and classification using machine learning model. And also, I show you the difference from deep learning to machine learning and what is the data most importantly to this kind of a algorithm model is what we can say. So for the next week, we'll talk about how to use deep learning model to do the same task using, I will show you that the PyTorch algorithms, how to obtain these classifications and regressions you need. And also we'll have some ideas that you can show, you can obtain from the data set, and how to manipulate it or clean data. We will need the regulations and some normalizations, and also show you some techniques in deep learning, what is overfitting, what is underfitting, and how to fix overfitting and underfitting. Okay. So any question for this week? So there will be no homework this week and no lab exercise this week. But for next week, maybe we'll I will see how the lectures goes. Maybe we'll have lab exercise next week. I will talk to TA, and if we do have, they will be taking place from maybe 11:30. So the lecture will be 9:30 to 11:30 with no recessions. And then we'll have a lab exercise. You can finish it, and you can leave the lecture. You can leave the classroom. Okay. So if we have lab exercise, it depends on the progress of the next week. Okay. Good. Any questions? No. So enjoy the week. So we'll have midterm on April 22nd. Remember that. And for next week, please remember to install PyTorch in your workstation or laptop. We'll need PyTorch next week. Okay. See you guys. Have a good one. 谢谢啦，辛苦你了，小猫。好啦，那就麻烦你咯，我等一下再试试看能不能把你加进去啊。好，谢谢，辛苦了，拜拜。
谢谢老师。
拜拜，拜拜。